Hello everyone. Firstly introducing me and my fellow teammates. Myself, ANSHUL JAIN, and I'll introduce the topic and the question, followed by SANATH, who will explain in detail with the flowcharts. Then AMITH will explain the code, followed by ARPIT, who will explain the desired outputs. So our topic is CSMACD, which stands for Carrier Sense Multiple Access with Collision Detection. And the problem for this topic is to write a C or C++ or Java program to implement CSMACD using non-persistent method. Consider at least 6 stations that are sharing a communication channel. Whenever it needs to send data, it senses the channel, and if channel is free, applies P persistent algorithm to send the data. If collision occurs, it should use exponential backoff timer and try for retransmission later. So carrier sense multiple access with collision detection is a media access control method used most notably in early Ethernet technology. For local area networking, it uses carrier sensing to defer transmission until no other stations are transmitting.
Have you thought how computers send data on a network without interfering with the data from other computers? When we think about it, we realize that there would be n number of collisions that is there by the data packets that will constantly be smacking into each other in all the network traffic. So, this was developed in order to not only help avoid collisions but also to respond appropriately if a collision does happen, and is called CSMACD. That stands for Carrier Sense Multiple Access with Collision Detection. This is basically used in half duplex networks that utilize coaxial cables and earlier versions of twisted cables. CSMACD basically works by each computer first sensing if the wire is idle, and if it is idle, then it sends its data. But if two computers send data at the same time, then a collision will take place. And if collision happens, the computer will wait in a random amount of time and retry to send the data. Let me explain this to you using a figure so that we can understand this in a more easier way. So here we have four stations, namely A, B, C, D. You can consider any number of stations, but for our convenience, I'm using only four. Now, in this method, a station monitors the medium after it sends a frame to see if the transmission is successful. If so, the station is finished. If, however, there is a collision, the frame is sent again. Although each station continues sends bits of frames until it detects the collision. We show what happens as the first bits collide. In the above figure, stations A and C are involved in the collision. At time t1, station A has executed its persistence procedure and starts sending the bits of its frame. At time t2, station C has not yet sensed the first bit sent by A. So, station C executes its persistence procedure and starts sending the bits in its frame, which propagate both to the left and to the right. The collision occurs sometime after time t2 dash. Station C detects a collision at time t3, which is received by the first bit of A's frame. So, station C immediately or after a short time, but we assume it to be immediately, aborts transmission. Station A detects collision at time t4 when it receives the first bit of C's frame. Even station A immediately aborts transmission. Looking at the figure, we see that A transmits for a duration t4 minus t1, and this duration we call it to be a transmission time, which is shown in the figure. Now, and this second figure is where the part of A frame is colliding with the part of C's frame, and C transmits for a duration of t3 minus t2. Later, we show that for the protocol to work, the length of any frame divided by the bit rate in this protocol must be more than either of these two durations. At time t4, the transmission of A's frame, though incomplete, is aborted. And similarly, at time t3, the transmission of B's frame, though incomplete, is aborted. And this is the procedure that I had just explained. And these are the energy level graphs. That is the energy level during transmission, idleness, and collision.
We have implemented the CSMA CD using C language. The type of data structure we have used in this code is structures, so that it will be easy to increase any number of stations we require to transmit data. First, I will be explaining the main function. In this first, we will ask the user to enter the number of stations. Then, for every station, we will ask the user to enter 1 if the particular station wants to transmit the signal. Else, you can enter any character. If the particular station wants to transmit the signal, then user has to enter its destination station and the time required and also data to be sent. We have used data to be sent in as 3-bit data. Once all the data has been entered, we'll go to the send data function. In this function, first we'll select the minimum time required using the function initial station. In this function, we'll get the minimum time required, and again the minimum time required will be stored in the send data function as t minimum. And again, if there is no backing off of signal or collision, then we will send the data which is given in the send function. Using the formula 2 power n minus 1, we will decide which station has to transmit the signal first, where n stands for number of packets being sent for that particular station. We use this formula 2 power n minus 1 if there is a collision between two stations which are transmitting the data. If the data gets collided again and again, we calculate 2 power n minus 1 recursively and transmit the data depending on the time we get. Similarly, all the signals will be sent bit by bit to the destination station. We'll get the output in the order of data bits sent along with the station number.
Now, let us understand the inputs and outputs for the above code. But first, we have to understand collisions more deeply. So, when all the devices over a network share same transmission medium and two or more devices sense that the cable is idle and they send their data at the same time, collision happens. And when they sense collision, they immediately stop sending the data and instead transmit a jamming signal out on the network, and this notifies all the other devices on the network that a collision has occurred, and now these two computers or devices will wait for a random amount of time before they send their data again. So as we can see here, first we ask the user to input the number of stations, which in our case is 6. For every station, we ask the user to enter 1 if the respective station wants to transmit signal. Otherwise, he or she can enter any bit or any character. Then we ask the user for the time for sending each bit of data, followed by the destination station. Then we ask the user for 3-bit data to be transmitted. We do this for all number of stations that user has entered. Now the input part is complete and the program executes our input on the basis of above code. If any collision occurs in between, like here, collision has occurred, the jamming signal is sent and backup function is called. It handles the situation as stated by my friend while explaining the code. So the data continues to be sent on, and according to the program, at last data is sent successfully without any interference. Now we can talk about some applications of CSMA CD. CSMA CD was used on early Ethernet networks and is not as relevant today because it was only relevant for half duplex networks, and today the networks we use are full duplex networks. So thank you.